an isolated footing. In this video, you will learn to interpret the design results of the isolated footing in the software. This is a continuation of the steps in the previous video. Open the saved file, if you have closed it before. If the punching shear ratio is not displayed, repeat the last step of the previous video. Just go to the display menu, and click on Show Punching Shear Design. Once the punching shear ratio value is displayed, right-click on the center point of the footing. The punching shear design details will be displayed. Here, all the design properties of the isolated footing are displayed, which include effective slab thickness, effective punching perimeter, the section inertia, moments and shear forces. You can change the load combination to see the results if there are any differences. Click on Done to close the punching shear details box. Now you will check the forces along the design strips that you had drawn. Go to Display, and click on Show Strip Forces. Here choose the load case or the load combination, for which you want to view the results. Then select the component, which you want to be displayed, like moment, axial force, shear force, torsion. Select the design strip layer, along which you want the results to be displayed. The display option has two options. One is Fill Diagram, that displays a scale diagram of the component, according to the values, and the other will show the values directly. You may toggle between each of the different options, for loads, component, design strip layer, and display options, and check one by one. Here as an example, the load case chosen is dead. The component selected as moment. The strip layer is A. And the display option is both Fill Diagram and Show Values. Click on Apply. The moment diagram for the dead load is displayed on the footing, over the strip layer A, along the X direction. Hover your cursor over the strip layer, and the moment values at each and every point is displayed. Select the Shear Force option. Select both layer A and B, and click on Apply. This time, the shear forces diagram along both the strip layers A and B, that is along the X and Y directions respectively, are displayed. Here too, you can hover your cursor over the design strips, to check for the shear force values at every point. Uncheck the layer A option, and click on Apply, to see the values only on layer B. In this way, you can try out with the other options. Click on Close, once you are done. Next, go to Display, and click on Show Slab Design. The Slab Design dialog box appears, where you will have to choose the required options. Select the Design Basis option, as strip-based. You need not make any other changes for now. Click on Apply. Click on Close, to remove the box. Now the reinforcement intensity, for both top and bottom bars of the footing is displayed. This intensity value is given in millimeter square per meter, that is area of steel in millimeter square, per 1 meter length. Once again go to Display, and select Show Slab Design. Here check on the Impose Minimum Reinforcing option. This option is used to display the code-mandated minimum reinforcing when it exceeds the required amount calculated by the software. Click on Apply, and close the box. Now you can see, the reinforcement intensity values are different from before. Now the bottom bar's reinforcement is 600 mm square per meter, which is higher than the previous values. This means, the minimum reinforcement as per the code is 600 mm square per meter, whereas the software had earlier calculated its own values, based on the design results, which were lower. So you have to take this new reinforcement intensity values, as per the code. Go to the Display menu, and click on Show Tables. Expand the Design Results option by clicking on the plus sign. Next, expand the Concrete Design option, and the Concrete Slab Results option. Mark the first table that is flexural and shear data. Then, click on OK. The table displays the flexural and shear information at different positions, in both strip layer, A and B. Here, The CSA4 is for strip layer A, and CSB3 is for strip layer B. Thus, at each mentioned position or station, the results like shear force, axial force, etc., are displayed. Under the status text, all the stations are marked as OK. If they are marked as failed instead, it means the footing has failed at that station flexural, although the footing may pass under punching shear. In that case also, you will have to redesign the footing. But usually if a footing passes structurally by virtue of punching shear, it also passes by flexural shear. Still, it is safe to check here too. Click on Done to close the box. Now that the design check is done, and you have fixed the footing dimensions, you will now generate the detailing diagrams of the reinforcement. Go to Run, and click on Run Detailing. Mark all the 3 options, and click on OK. The different detailing diagrams have been generated, which you can view one by one. Go to the Detailing tab of the Model Explorer. Expand the Drawing Component Views option. Again, expand the Footings Views option. The footing layout plan is already displayed by default. Next, select the Footings Table option. Zoom in to see the table clearly. The lengths in X and Y, as well as the thickness, is displayed. Next, the number of rebars in each direction is mentioned. Verify the directions A and B from the diagram below. Rebars A are the ones in the Y directions, and rebars B are in X direction. So, in A direction, there will be 4 bars of 12 mm diameter, and 5 bars of 12 mm diameter, in the B direction. You can expand the Drawing Sheets option to see the reinforcement diagrams in the form of plan drawings. Explore the other options in the Detailings tab to check for the other detailing information. So you have successfully designed the isolated footing in the software. In the next video, you will learn about combined footings. Thanks for watching.